Good morning, guys. Myself is Ramesh Kumkale. Today, we are going to start with second PUC physics. Uh, I am going to start from chapter 1 only. Here, I am concentrating both theory as well as NEET level concept clarification. I will help you out in both the way, in theory as well as NEET. Okay. Uh, Before diving into the subject, it is my humble request. Please like, share, and subscribe my channel so that easily you can get my next video. Okay, let us start with electrostatic without making any delay. Electrostatics chapter deals with a charge at a rest. Static means rest. Electro means it is a terminology which deals with charge, means charge at rest. Okay, electrostatic. We need to understand first what do you mean by electrostatics. So it entirely deals with the charge. What is charge? What are the types of charge? And what are the basic properties of charge? On what principle they are uh, exist? How they behave? All those things we will discuss. What is the basic law? It can explains whether they attract or whether they attract, if they are attracting, with what force they are attracting, if they are repelling, with what force they are repelling, we need to know. Okay, so electrostatics, here it discuss about charge. Okay, so what do you mean by charge? To know what do you mean by charge, we need to discuss some experiments. Let me take a glass rod. This is a glass rod. A glass rod. A glass rod is rubbed with silk. If I rub a glass rod with silk, and I will repeat this experiment with another glass rod and silk. I am going to rub this glass rod with the silk and this glass rod with the silk. After rubbing, if I try to bring these rod glass to close each other, they start to repel. They start to repel each other. And one more experiment. I will take a plastic rod, two plastic rod. This is rubbed with cat fur. Rubbed with cat fur. These are plastic rod. Okay. See, here I took glass rod rubbed with a silk cloth. After rubbing, if I try to bring these two glass rod close to each other, they trying to repel. They repel each other. Again, if I take two plastic rods, if I rub them with a cat fur, after rubbing, if I try to bring these two glass rods to close each other, they start to repel each other. This is the second experiment. Okay, after this experiment, one more observations what we observed that one glass rod rubbed with silk, one plastic rod rubbed with cat fur. If I try to bring them close, they start to attract each other. They start to attract each other. See, if two glass rod rubbed with a silk, If I try to bring them close, they repel each other. Again, conducted experiment by taking two plastic rod rubbed with a cat fur. If try to bring those two plastic rods close to each other, then again they will repel each other. And if I take uh, plastic rod glass rod and plastic rod close to each other, they are attracting. By this means, after rubbing, some transformation has taken place. Due to that, they are behaving in such a way that they may attracting or they may be repelling each other. So something is transferred between a glass rod and a silk cloth. Something is transferring from rod to silk, silk to rod. Plastic rod and cat fur, after rubbing, something is transferring from one to another. One is donating, another one is receiving. Because of this taking and gaining, there is a change in their behavior. There is change in their behavior. They may attracting or they may repelling. So something is transferring from one to another. This taking and gaining, because of that, there is a change in their behavior. Okay, so this happening now after the being, they behaving like attracting, they repelling. This procedure is called as electrification. Electrification, my dear friend, electrification is the process of donating or receiving an electron from one body to another body is called as electrification. Electrification can be done by rubbing. Glass rod is rubbed with a silk, there is a transfer of charges. Plastic rod is rubbed with a cat fur, again there is a transfer of charges. So transfer of charges from one body to another body, that process is called as electrification. Mainly in electrification happens, what happens in electrification, the transfer of electron takes place. Okay, by this what we come to know that by rubbing we can make a two body charge. They become charged only when one is ready to lose the electron and another one must accept. That is called as electrification. See, the body which donates electrons, the body, let me take the electron are transferring from a glass rod to silk, glass rod to silk, electron are transferring. If the electrons are transferring from glass rod to silk, then it is losing electron. The body which are the material which lose the electron, it become positively charged. The body or a material which receive the electron, it is negatively charged. My dear friend, during the process of electrification, by means of rubbing, the charges are transferring from one body to another body. If the charges are transferring from one body to another body, then only they will become charged. Yeah, the body which lose the electron, it become positively charged. The body which receive the electron, it become negatively charged because excess number of electrons takes place. Here, adequate number of electrons takes place. This is called as electrification. This by means of this is positively charged and this is negatively charged. Again, this is positive, this is negative. By means this is a positive polarity and this is negative polarity. Means polarity is the property which differentiate between the two types of charges. One is positive charge and another one is negative charge. This is the polarity. Polarity is the property of the material which decides or which differentiate between there are two type of charges. One is positive charge and another one is negative charge. This is called as polarity. Okay. So now there are types of charges. See, with this experiment, what we come to know that what is electrostatic? This electro means electron, something related to charge. Let me consider charge, electric charge. Okay, if I classify this charge, there are two type of charge. One is negative, another one is positive. Example for negative charge is electron, and example for positive charge is proton. Proton is positively charged, electron is negatively charged. The charge of electron is 1.6 into 10 power minus 19 coulomb. Proton, the charge of proton is also 1.6 into 10 power minus 19 coulomb. Coulomb is the SI unit of charge. What is 1 coulomb? We will discuss that 1 coulomb definitions in Coulomb's law. Okay. The charge on electron is represented by minus, the charge on proton is represented by positive sign. 1.6 into 10 power minus 19 coulomb is the charge of electron. 1 point plus 1.6 into 10 power minus 19 coulomb is the charge of a proton. There are two types of charges. One is negative charge, another one is the positive charge. Okay. See, what we discussed in an experiment, a glass rod and silk cloth. If these two rubbed each other, there is a transfer of electron from one body to another body. If I try to keep them in contact for some time, after some time they no longer will be the charged one because they attain neutrality. They attain neutrality means they no longer attract each other. They no longer attract each other after the transfer of electrons. One received electron, one donated electron. They no longer attracting each other. Okay, hence because of that reason, means if we keep them contact, they no longer in attraction, right? So this is what I wanted to say. This is called as electric neutrality, means they don't conduct. Next is we need to know properties of charge, the basic properties of charge, basic properties of charge. Property number one, charges are additive in nature. Charges are additive in nature means what? The total net charge of an isolated system is the additive nature. Means, let me consider a system. System has charges Q1, Q2, Q3, Q4, Qn. Means this system A has n charges, namely Q1, Q2, Q3, Q4, Q4 and Qn. Then net charge. What is the net charge of the system? Means we are going to add Q net. Q net is equal to what? Q1 plus Q2 plus Q3 so on plus Qn. This is nothing but additive nature of charge. Means we can add, by adding these all distinct charges, we are going to get the total charge on the system. What is the total charge on the system? That is Q net. Q net is equal to Q1 plus Q2 plus Q3 so on Q1. The total net charge of the system is this. So hence this is additive nature of charges. Means we can add the charges, we subtract the charges. Okay, hence the charges are additive in nature. I think you come to know the total net charge of a system is Q1 plus Q2 plus Q3 so on Qn is called as additive nature of charges. This is a system. Consider a system A has charges Q1, Q2, Q3, Qn so on Qn. Then what is the total charge of the system? We need to add. After adding, we will get the total charge on the system. That is Q net is equal to Q1 plus Q2 plus Q3 so on Qn. This is the first property of charge. First basic property. Second property. Second property is charges are conserved. Charges are conserved means the total net charge of an isolated system is always conserved. I will repeat again. The total net charge of an isolated system is always conserved. It means what? Before we last minute we discussed about one experiment. A glass rod rubbed with silk cloth, the transfer of electron takes place from one body to another body. But there is no creation or destruction of electron takes place. Yes? Just the electrons are transferred from one body to another body. No more further creation or destruction of electrons takes place. Hence, because of that reason, charges are conserved in nature. As you people studied in your classical mechanics, there is a law of conservation of energy. Energy neither be created nor be destroyed, but it can be transferred from one form to another form. So similarly, the charges are also conserved. Charges can transfer from one body to another body, but we cannot able to create or destroy the charges. Just we can transfer. Means one electron is transferring from glass to silk cloth. It doesn't mean that there is a destruction of charge take place. No, the charges are transferred from glass rod to silk. Are you getting? Charges only can transfer from one body to another body. So by this is the meaning of charges are conserved. Means the total net charge of an isolated system is always conserved. You cannot destroy or you cannot create the charge, but you can only transfer from one body to another body. How you can transfer a charge from one body to another body? By the process of electrification. By the process of electrification. By the process of electrifications. Electrification can be done By rubbing each other. By rubbing two bodies, there is a transfer of electrons takes place from one body to another body is called as electrification. This is the second property of a charge. Okay. Again, the third property of a charge. Third property of a charge. Charges are quantized. Charges are quantized. Charges are quantized. It means what? The free charge on a body is always integral multiple of E. Again, I am telling the free charge is always integral multiple of basic charge of electron. Basic charge of electron. Basic charge of electron is what? E. So charge, free charge is equal to Ne, means integral multiple of E. Q is equal to Ne. Q is a charge, N is the integral multiple where E is the charge on electrons. Okay, so charges are quantized, means Q is equal to, actually it is plus or minus Ne, because we have two types of charges, negative charges and positive charges. Because of that reason, Q is equal to Ne. Okay, where E is the charge on electron. What is the charge on electron? We discussed that is 1.6 into 10 power minus 19 Coulomb. This is the charge on electron. See, if there is a 1 Coulomb of charge, then how many electrons are there in 1 Coulomb of charge? If we want to calculate, I will show you how to calculate. See, Q equal to Ne, charge is what? 1 Coulomb. Means 1 Coulomb is equal to N into 1.6 into 10 power minus 19. 10 power minus 19. So then we need to calculate the number of electrons present in 1 Coulomb. So means transfer this value. So then N is equal to 1 divided by 1.6 into 10 power 19. Okay, by transferring it become N is equal to 0.625 into 10 power 19. So then N is equal to 0. Sorry, if I transfer 1 0 here, it will become 6.25 into 10 power 18. These many number of electrons present in 1 Coulomb, keep in your mind. Sometime NEET will ask questions on this type of easy topic. This is the charge on, sorry, these are the number of electrons present in 1 Coulomb. How many? 6.25 into 10 power 18 number of charges are there. Sorry, electrons are there. Right. Charges are quantized in nature. Means charges are having only magnitude but no direction. Charge is a physical quantity. Charge has magnitude but charge has no direction. It means charge is scalar in nature, like masses. Charges are scalar in nature, like masses. Scalars are having only magnitude but no direction, right? So charges are scalar like masses. But my dear friend, there is a difference between charge and mass. What is the difference between charge and mass? Masses only attract each other. One mass can attract another mass. But in case of charge, it happens both. Both means they may attract or they may be repel. That is the next property we will discuss. See, here my duty was to make you understand that charges are scalar like masses. But we need to understand the thin line difference also, right? So masses are always attract. One mass never repel another mass. Mass always attract another mass. But one charge, it may attract another charge, or one charge, it may repel another charge. Both the cases are possible in charge. This was the basic difference we need to know. Charge is scalar. Why is charge is scalar? Because it has only magnitude, but there is no specific direction. Hence, charge is quantized in nature. You come to know the third property of charges. The fourth property of charge is repulsion is the sure test of charge. Repulsion. Repulsion is a sure test. That is fourth. Repulsion is the sure test of charge. Because let me consider mass 1, another mass 2. There is always force of attraction between these two. There is always force of attraction. As I told before, masses always attract. Even charge also attract. Q1, Q2. These also attract. These also attract because charges are also having mass. Mass of electron. Mass of electron, that is 1.6, sorry, 9.1. 9.1 into 10 power minus 31 kg, nearly. This is the mass of one electron. Mass of one electron is 9.1 into 10 power minus 31 kg. Means two mass attract. Here electrons also attract. Electrons having mass. But electron exhibit one more property, they repel each other. Why they repel each other? If the charge on both the electron is same. Negative charge repel. Negative charge, positive charge attract. Okay. So repulsion is the sure test of charge. Charge ಅಂತ ಹೇಳಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ they must repel each other. ಯಾಕಂದ್ರೆ if we consider attraction, mass also attract, charge also attract because charge are having mass, that is 9.1 into 10 power minus 31 kg. Right? So repulsion is the sure test. One thing keep in your mind, charge never be fraction. Charge may be negative, charge may be zero, charge may be positive, but charge never be fraction. The least possible charge of electron, keep one thing in your mind, the sorry least possible charge is 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 9. This is least possible. You never get less than this. It means you never get a charge less than this. The least possible charge on universe is 1.6 into 10 power minus 19. You never get less than this. But you get larger than this, but you never get less than this. Okay. So this is the sure test of repulsion, is the sure test of charges. Fourth property is easy. What? Like charges attract each other, and unlike charges, sorry, like charges repel, unlike charges attract each other. Means proton and electron attract because they are opposite charges. Proton repel, electron, electron, repel. Okay, I hope you enjoyed the today's class. In the next class, we are going to discuss about Coulomb's law. See, this is the basic you need to know, and with the help of this, there is an interpretation of force. What is they are if the two charges are repel, when they repel, electron electron repel, proton proton repel, proton electron attract. Means like charges always repel each other, unlike charges are always attract each other. If they are attracting, with what magnitude they are attracting, if they are repelling, with what force they are repelling each other, all these things we will discuss in the next class. Thank you for watching. All the best.